Today I'm discussing the data types in C language. The data type in C defines the amount of storage allocated to variables, the values that they can accept, and the operation that can be performed on those variables. C is rich in data types. The variety of data types allows the programmer to select appropriate data type to satisfy the need of application as well as the needs of the different machines. There are three types: primary data type, derived data type, user defined data type. Primary data type are fundamental data types or basic data type. Almost all the C compiler supports these primary data types. Integer, character, floating point, double precision floating point, void data type. The integer can be written the int, character can be written the char, floating point can be written the float, double precision floating point can be written the double, void data type can be written the void. The range of the integer is the minus 32768 to 32767. The range of the character is the minus 128 to 127. The range of the floating point 3.4 exponent power minus 38 to 3.4 exponent power 38. In double, 1.7 exponent power minus 308 to 1.7 exponent power 308. The format for the integer is the percentage D. The format for the character is the percentage C. The format for the floating point is the percentage F. Format for the double is the percentage LF. Void data type can be used in the functions when no value is to be written. At that time we are using the void data type. Next one is the integer type is classified into signed and unsigned, that are int, unsigned int, short int, unsigned short int, long int, unsigned long int. Character type is classified into signed and unsigned, that are signed char, unsigned char. Float type is classified into float, double, long double. Void type is the void. I already explained that one. This void data type can be used in the functions only. This particular table, I explained the data types, the size, range, and format. First one is the char or unsigned char. The size is the 8 bits. The range of the character is the minus 128 to 127. Already I discussed in the case of the previous one. The format is the percentage C. Unsigned char, that is the 8 bits. 0, the range is the 0 to 255. The format is the percentage C. Integer is the 16. The range is the minus 32768 to 32767. The format is the percentage D. Unsigned int, the size is the 16 bits. Range is the 0 to 635,536. The format is the percentage D. The short int or signed short int, the size is the 8 bits. The range is the minus 128 to 127. The format is the percentage D. Unsigned short int. The size is the 8 bits. The range is the 0 to 255. The format is the percentage U. Next one is the long int or signed long int. The size is the 32. The range is the minus 2147 483 648 to 2147 483 647. The format is the percentage LD. Next one is the unsigned long int. The size is the 32 bits. The range is the 0 to 4294 967 295. The format is the percentage LU. Next one is the float. 32 bits. The range is the 3.4 exponent power minus 38 to 3.4 exponent power 38. The format is the percentage F. Double is the size is the 64 bits. The range is the 1.7 exponent power minus 308 to 1.7 exponent power 308. The format is the percentage LF. Next one is the long double. The size is the 80 bits. The range is the 3.4 exponent power minus 4932 to 1.1 exponent power 4932. The format is the percentage capital LF, capital L, small f. Here I discuss this particular table. The size is the 8, 8, 16, 32, 64, 80. These are bits. 1 byte equals to 8 bits. And also in the range I discussed that is for the character minus 128 to 127, unsigned char 0 to 255, and short int minus 128 to 127. That means the range of the character is within this particular numbers. Within this particular range, it can accept the numbers minus 128 to 127. In the case of the unsigned char, it can accept the 0 to 255. Same like at these different data types. And also here format the percentage C, percentage D, percentage LU, percentage LF. These format specifiers are using in scanf, printf functions. In the scanf, you have to mention that one. If the data type is the character, you have to use the percentage C. If the data type is the integer, we have to use the percentage D. If the data type is the double, we have to use the percentage LF. Same like in the case of the printf, we have to use the percentage C, percentage D, percentage F. If the data type is that one. Okay, understood? Now, this particular table is that is the 16-bit mission or 16-bit compiler only. It means the range is within the 16-bit mission or 16-bit compiler. Now, if we want to know the size of the integer, character, float, you can use the size of operator. I will explain later. Next one is the user-defined data type. By using a feature known as type definition that allows user to define an identifier that would represent a data type using an existing data type. The general form type def, type identifier, or type def existing data type to new user defined data type. Once again I am repeating, type def existing data type to new user defined data type. Next one is the derived data type. Those data types which are derived from fundamental data types are derived data types. They are basically three derived data types that are arrays, string, structure. Next video, I will explain the arrays, strings, and structures. The pictorial representation of the above data types. Here, now data types in C: primary DT, user defined DT, derived DT. DT means data type. When you observe this one, char, that is signed, unsigned, float, float, double, long double, int, long int, unsigned long int, and also same like at the void. User defined data type, enum, type def. Derived data type, arrays, structures, pointers, unions. Come back to the size of operator. If we go to the example program, if we observe this one example program, printf size of int, printf size of char, printf size of int, printf size of char. The storage size for int is the 4 bytes. Storage size for the char is the 1 byte. Understood?